In this video, we're going to look at Lewis structures, molecular shape, and hybridization for H2S. So the first step is to draw the Lewis structure. So we could do that. We'll sort of do it the slower way. We'll count up all the valence electrons. There's 2 from the hydrogen, 6 from the sulfur, so we've got 8 valence electrons to account for. Sulfur in the middle, we'll arrange the hydrogens symmetrically. We put in at least a single bond. Well, in this case, it can only be a single bond because hydrogen cannot have anything but a single bond. So we've got 4 more electrons to draw, and they have to go on the central atom. And by doing so, sulfur completes its octet. So that's the Lewis structure. One thing you remember from when we learned about VSEPR was that if you have 2 lone pairs on the central atom, they push the bonding pairs down, just exactly the same as they do in H2O. So actually we should probably draw this in such a way as to reflect that. Okay, so the shape of this molecule is bent, or sometimes it's called V-shaped. Both are acceptable. Now before we get to what I just inserted here, if you look at our diagram up here, there are 4 regions of electric charge around the sulfur. There's 2 bonding regions and 2 lone pairs. So that's 4 regions of electric charge. That corresponds with sp3 hybridization. Now if we look down at the diagram, we'll see what's happening with regards to the valence electrons. Notice that sulfur is in the same family as oxygen, so it has 6 valence electrons. In this case, they're in the 3s and the 3p orbitals. Now when it hybridizes, in sp3 hybridization, that means that all 3 of the p orbitals are going to be involved in hybridizing, and we get 4 hybrid orbitals. Okay, so let's draw all 6 electrons there. Well, you'll notice that these 2 orbitals are already full. These orbitals represent the lone pairs on the sulfur. The other 2 orbitals are going to be the ones which get filled up by the hydrogen's valence electron. So there's the 2 valence electrons, one from each hydrogen. And these are making sigma bonds, right? Because they're single bonds, they're sigma bonds with the hydrogen. And we could draw that up here as well.